Okay, here we have our floodplain model. And this model for scale is like 4 feet wide. It's like this. And this model came to us from MCDD, which is Multnomah County Drainage District. And the goal here is kind of to understand how water flows when we're talking about precipitation and some of the problem solving that we can do to reduce flooding. So you might remember a lot of changes that have happened in the last 150 to 200 years here in our watershed. And a major one is that we have way more impermeable surfaces than before. When you look at that map from 1852, everything was a permeable surface. Permeable means it can absorb water. But today, 2/3 of the surfaces in the watershed are impermeable. So it's things like streets and parking lots and roofs on buildings. All these things cannot absorb water. So only 1/3 of the land is able to soak up precipitation. Right now we've got this parking lot in here, and I put a little car on there, and we're just gonna see what happens when it rains in these two rainmakers. Is it gonna flood? Woo! Is it gonna flood? Is it gonna flood? And we can see the answer is yes. Too much water in one place in a short amount of time. That little airport island over there got flooded, and it's already drained out, but this neighborhood with the green houses in it that's down by the water also flooded. There's a few things that people have done to try to solve the problem of flooding. And one of those things is building levees. And you remember, levees are those hills that are made out of sand and gravel that protect the land from the river. Can you see this? This is a bunch of modeling clay that came with this kit. And I always find it really curious why we're supposed to be using modeling clay for this when we specifically went over the fact that clay is not permeable, and so it's gonna have a bunch of pressure on it. I want to try protecting this little neighborhood down here. So I'm gonna put a levee right here to protect these houses from the river. So here is our rainstorm come back again. Upland and on top of the land. Uh-oh. Wipe out. There's some problems that happen with this problem solving. One thing that this clay is doing a really good job holding water that is flowing down off this land inside of it. And we don't want that. We want our levees to be able to drain. Multnomah County Drainage District is cool because they also have a bunch of pumps going on that pump this extra water from here out into the river. And that way, even if a lot of water is coming down off of the land, the levee is good at protecting from the river, and then the pumps empty water off of this side of the land. We're going to talk about risk right now. And do you think that maybe the people that live in all these little greenhouses down low are in a high risk position? Yes, they are. It is high risk to live there. And so something that's happened is the city has zoned certain areas of our watershed to be residential, and then certain areas cannot be used for housing anymore. That's one reason that you see a lot of industrial land use in this area, is because it's too high risk for homes to be there. I'm going to be taking these houses out of the risk zone and putting them higher up so that they're at least out of the way. And what's okay to be down here? Well, the airport. And I'm going to position this so it's easy for water to flow around the levee and for this area to be protected. Maybe now that it's like that, some of the extra water will go around the levee and this area will be protected. Now I have one more thing. Remember how I was saying we have these impermeable surfaces? What if we replaced that parking lot with a wetland? Let's see. Okay, there is our wetland. And what is wetland actually full of? Sponges. Wetlands are really absorbent, very permeable. So what we're gonna see right now is how much a difference it makes to have water absorbed in the upriver. And then how does that affect the rest of the floodplain? I'm gonna pour an entire pitcher of water on the wetland, and I want you to see how much of it gets into the river. This is like our atmospheric river. And when I say atmospheric river, I mean like 5 inches of rain in 2 days. Oh my goodness! That wetland is holding on to an entire pitcher of water. Barely any of the water is coming out of the wetland and going into the river. But the water that is coming out really slowly and gently. Wow. That's kind of like the opposite of flooding. Instead of too much water in a short amount of time, it's a little bit of water over a long period of time. And that is just how I like it. So you may have noticed I only poured water on top of the wetland. That does not change the permeability of the rest of this land. You remember how I said that like a lot of our city is covered in impermeable surfaces? We can change our city to make it more absorbent. And the one thing we can do is add plants. Do you think these plants are gonna make a difference? Do you think they're gonna be very good at soaking up a bunch of the rainwater? We are gonna find out. All right, let's see what happens when we pour a whole lot of water, not only upstream, but also on the watershed. Are those plants making a difference? I think they are. Turns out plants make a big difference. These houses are where they're supposed to be. They're not being flooded. This levee is letting water out the side, which is cool. This airplane and the airport that we're pretending it's a part of is protected from the river. So it looks like if we can put more plants around our watershed, not just upstream, but also around where the water is falling on the land, then we can prevent flooding. And then, go with the classic levee protection. So levee and pumps are infrastructure that are built and maintained, but then these plants and wetlands are green infrastructure that aren't gonna break and crack and need to be repaired. They're gonna do that work of holding and slowly releasing the water and preventing flooding without us having to do a bunch of expensive work on it. I wanna say thank you, Model, for showing us how it works. And I think I'm gonna talk about Vanport too.